For thousands of years, man has looked out into the galaxy beyond our solar system in awe. The future is here. Today, the Tabula Rasa project has created Deep Space 8, a true voyage of exploration out into the known universe and beyond, to discover and answer fundamental questions of science.
We plan to construct the main body of Deep Space 8 out of aerogel. Alloy X114 is perfect. It's a good insulator, incredibly strong, able to withstand pressure, and, being 99.9% air, has a very low mass. Gold foil will be layered around the fuselage for extra protection against radiation. The interior will be mainly composed of aluminium alloys due to its low density and availability.
The ship will be split into rotating compartments, inducing a gravity-like force to combat some of the negative effects of long periods in zero gravity. The ship will have gym, dormitories, kitchen area and lounge. A detachable and disposable arm will assist with docking DS-8 to the ISS. Further, a radio transmitter, receiver and interpretation software shall provide DS-8 with its essential communication network.
We'll harvest solar energy using solar arrays made of thin film photovoltaic cells attached to the support structures extending from the ship. This will satisfy both the propulsion and energy needs of DS-8. To increase efficiency, we'll use concentrator arrays with Fresnel lenses to intensify light onto smaller areas.
Propulsion is provided by high-thrust ion drives recently developed by NASA's laboratories. Due to the lack of air resistance in space, once the ship has reached a sufficient rate of acceleration, the drive can be switched off until needed, saving resources while maintaining velocity.
Energy temporarily not required is stored for use when light is less available. A hybrid flywheel energy storage system replaces inefficient chemical batteries, making use of a carbon fiber rod spinning up to 50,000 RPM suspended within magnetic bearings. Thanks to a lack of friction and alignment with rotation, an efficiency of around 85% may be achieved.
Being in space for months could have negative mental outcomes, but green areas and VR will be employed in order to enable the crew to relax. To combat the effects of radiation, astronauts will wear spacesuits embedded with lead nanoparticles, as the high molecular density is effective at stopping gamma and X-rays.
DS-8 has a sustainable approach for growing food. We plan to cultivate vegetables via hydroponics. Protein will be artificially produced via the use of fusarium fungus, producing mycoprotein that can be harvested.
A renewable supply of water is produced by combining hydrogen from pyrolysis and CO2 naturally produced by the crew in the Sabatier reaction. The electrolysis of this water produces 2 to 9 kilograms of oxygen per day. Coupling this with pressurized oxygen stores, we have a sustainable supply of oxygen. The methane produced in the Sabatier reaction can be burnt to produce heat and hydrogen. The recycling, in addition to a water recycling system, will reduce waste. Any waste produced in the voyage will be flushed out into the storage tanks and periodically ejected.
Low-level lighting will be produced by utilizing a plant called Rusagard specimen, a genetically modified plant containing luciferin.
This is the DS-8 project. We are Tabula Rasa. We strive forward to the future, to imagine, to advance, to solve.